So I have the pleasure of sharing some research that I've been exploring for the last several years, actually, in the relationship between light and health. And my background's in nephrology. I did what nephrologists do for a long time. I took care of very sick people, end-stage renal disease, transplants, and just very briefly, both my parents developed end-stage renal disease. It was a really horrible coincidence. And that was about 20 years ago. I've been in practice 30 years. And so both my parents were on dialysis at the exact same time and had what typical cardiometabolic risk factors. And so I was their caregiver, and none of their docs ever made a decision without my blessing. It was an interesting journey, and they died young. They were in their 60s. And it was at that time that I began to question everything that I was doing. And it sort of shifted my timeline to one that brought me more involved in ancestral principles and nutrition as a second language, and mind-body science. And so a lot of what I do now is population health work in Western Massachusetts. And so much of that is about lifestyle medicine and applying population health principles to the masses, particularly those with more profound social determinants of health, those with health literacy challenges, lower socioeconomic status, many people who are disenfranchised. And so it's a great opportunity. But the whole concept of light and health is one that fits beautifully with an ancestral paradigm, because I think it can be said that modern humans have forgotten where they've come from, and we're a species with amnesia. And it seems with each passing generation, we've become more disconnected from those roots. And I think this topic of light and health kind of epitomizes that disconnect. And the research is getting more and more interesting. I also serve as, it's a CME event, so just by way of disclosure, I serve as the Chief Clinical Innovation Officer for a startup company in Cambridge, Massachusetts called Novolux. We are developing virtual window technology that in any setting can reproduce the light quality, spectral quality, lumens, circadian effects, parallax effects, and the company's been around for a couple of years now. We partner with Anderson Window, and right now we have prototypes in many places all over the world, but largely in the US, in healthcare settings, in government settings, and it's been an interesting journey. And most of that collaboration for me has been with the Rensselaer Polytech Institute in the Albany, New York area. Their lighting institute's a very sophisticated nanotechnology lab, and so I do that offline, and I also serve as the faculty for the Center for Mind-Body Medicine, which is a DC-based group. And I have a podcast, as so many folks have these days, called The Health Edge. And I do that with a fellow named John Bagnulo. John is an extraordinary guy. He's climbed Everest. He's a PhD in nutrition. John serves as the nutrition guy for the New England Patriots, and has been working with Tom Brady and a lot of high-level athletes for quite a few years. And so John and I connect and have a lot of fun with that. And so, and I don't know about you guys, but nobody ever taught me about Nikola Tesla growing up. It's hard to find Nikola Tesla in the history narrative, and his is a most remarkable life, and one that I continue to explore. And as Tesla once said, if you want to find the secrets of the universe, you have to think in terms of energy, frequency, and vibration. And this is quantum medicine. It's biophysics, and I think it's really the next chapter of medicine that we are going to be moving toward beyond the scientific materialism that we're locked into right now. And so just a few things that glad to share with you. I think, as everyone knows, disruption of circadian entrainment appear to be major drivers of all chronic complex diseases. The evidence for that is very good. In addition, if you work in hospital settings, as I have done for much of my life, there is no environment more disruptive to circadian entrainment than a hospital. And it's now widely recognized that anyone who's hospitalized is likely to confront post-hospital syndrome. That's well described in critical care settings. You know, I'm sure Bob has seen many people that undergo commando surgical interventions. They spend many days in the ICU. Even our amazing colleague Tommy is probably going to confront some interesting epigenetic alterations of his genome as a consequence of all that he's been through of late. And I think we're getting a better handle on the fact that our environments could not be more disruptive in the context of our desire to be healing. And then, of course, you know, we're living in modern environments that are more disconnected, of course, from our evolved and trained biologic systems. We'll look at some of that research and what the implications are. And of course, I would make the case that light and junk light is probably every bit as important as junk food. And we need to be more thoughtful in taking light inventory and understanding how the quality of light that a person is in relationship with each and every day is probably impacting or disrupting their health in a very significant way. So I love this, this term, Zeitgeber. Zeitgeber is a term that basically refers to a cue given by the environment, such as a change in light or temperature that just innately resets our biologic clocks. And so we've lost touch with many of the Zeitgebers. We now have too little time outside without full protection, right? We tell people to don't do that. And if you do that, you know, lather yourself up with carcinogenic topicals. The incandescent light, as I'll show you, really is a better approximation of color spectrum than most of our modern fluorescent lights. And we all understand the hypnotic effects of the fire. Red amber lighting, particularly after sunset, has very profound effects on neurotransmitter function, circadian and diurnal hormonal rhythms, and we could all be doing a lot more of that. And now we're doing too much of this, right? We're indoors most of the time, often in windowless environments. Certainly the quality of light from most of our technology now is very much skewed toward blue light, as I'll show you. The compact fluorescent light is just a complete disaster from the perspective of light quality. Certainly more energy efficient, but these are predominantly blue light on the color spectrum. I'll show you some spectral images of that. And of course, you know, we tell people to load up pretty heavily on sunblocks, which, you know, may have some value, of course. There's a sweet spot in terms of sun exposure, but many people are not only not benefiting from the potential of UVA light, but they're dousing themselves with many products today that have aluminum nanoparticles and other endocrine disrupting agents. And so not only are they not protecting themselves, but I would make the case that they're probably worsening their health risks. So here we are on this amazing planet, and I have to remind myself sometimes that, you know, right here, right now, we are moving about 1,000 miles an hour around the axis of the planet. The planet itself is moving about 66,000 miles an hour around the sun. We are in rapid motion, and of course, every life form on the planet has become synchronized with the predictable rise and fall of the sun each day. And in our modern lights, these are just photographs from space station. Ours is a planet now that is no longer dark at night. And you know, surely there's some value in modern life of having light, but Ours is a very different planet now in terms of light quality. And when you look at the history of light, which is so interesting, all of our ancient ancestors just inherently understood the value of light, the therapeutic value, the medicinal value, the spiritual value. Most of the caves that have been inhabited and for which you find various artistic works are usually directed toward the south, presumably because there was recognition of the hygienic value of light. And heliotherapy was a very popular therapy. Hippocrates prescribed this. Sunbathing was an important intervention for both medical and psychological purposes. And the ancient Greek Olympians would do their training outdoors in bathing suits in order to improve their performance capacity. They just understood that this was important for health and performance. And then turning the clock ahead to the turn of the 20th century, where the Danish physician Niels Finsen was awarded the Nobel Prize in Medicine for his recognition of the capacity to treat lupus with concentrated light radiation. And it opened up this field of light as a therapeutic intervention. And many of these lamps of hope, that were prototypes developed from his original research, were found to have important antimicrobial capacity, treating wounds, treating infections, and this was just widely recognized therapeutic potential that was widely disseminated. And many hospitals of the day had treatment rooms with higher intensity light, including ultraviolet frequencies of light, and individuals would lay beneath them for periods of time each day. And, imagine, I mean, does this not sum it up, right? What a nice day. So now if the Joint Commission comes to visit you and you're doing this, you will lose your accreditation. One of the great texts, this was in 1910, from Kellogg of the cereal. Many people don't know he was a physician. J.H. Kellogg, who had a tremendous interest in the therapeutic potential of light. And Kellogg wrote this book. You can get this online. It's a PDF. You can download it for free. It's a fascinating read. It's about 100 pages. And it's this beautiful examination of light and various clinical conditions and protocols for managing them. But again, this was how you optimize your health. And so now we're in this era of biophysics and quantum, and this is quite a rabbit hole. One that I have an inclination to like rabbit holes, and I've been in this one for a few years now. And we know that humans ultimately are biophotonic. And while ours is a paradigm that focuses very much on the material, that which is tangible, that which our five senses can somehow embrace and interpret, this is really where the action is. This is the realm of the subatomic. This is the realm of dark matter and dark energy, and it's estimated that 98, 99% of who we are ultimately is what occurs in this space. These are frequencies, geometric patterns of vibration and photonic energy expression. And so much of this research, which tends not to be easily embraced in Western mindsets. You look at the work of Fritz Albert Popp and Peter Darya. These are Russian scientists, Eastern European scientists. They have done some remarkable work looking at biophotonic emission patterns of humans and plants and animals, developing techniques to look at the energetic architecture of light, these matrices, the matrix. And again, these are ultimately complex frequencies that ultimately determine how the material appears, atomic structure, molecular structure, and there's some interesting evidence that if you take strands of DNA and you hit them with laser light while that DNA is in a tube, and then you remove the DNA, you will see the double helix of photons that will maintain preservation in the medium that that DNA was in for up to 30 days. There are light photonic signatures of that which is material, and current thinking is that the material comes from the light, not the other way. So again, all I think ancient wise traditions understood that we are light, and most wise traditions have ways of expressing that relationship. Heliotherapy was really quite popular, as I've alluded to, particularly into the 20s and 30s. There were many publications at the time that were coming out in terms of managing infectious diseases, lowering blood pressure. I'll show you some of that data in a second. Many illnesses that certainly at the time did not have the sort of the pharmacocentric approaches that we have today managed with light. And when we brought my son Alex home from the hospital, Alex is 26 now, and he had Down syndrome and had a very high bilirubin, and nobody really thinks twice about the Billy blanket. You know, this is a blanket with basically a frequency at 450. It's blue light. Cytochrome P450 is a chromophobe. It's a chromophore protein, as many proteins are in the human body, and you know, I think most of us are aware that you can alter bilirubin with light. In this example, that breaks it down and renders it more excretable. And so we've gone from this sort of ancient recognition of light as a source to a more modern heliophobic culture that somewhere between here and here, we have deprived ourselves of what may be one of the more therapeutic and free interventions on the planet. And so, yeah, you're all very familiar with this. And when I start to think about the senses and just light in general, we really are privy to a very narrow band of electromagnetic frequencies. This is a very thin slice of the electromagnetic frequencies that now bathe us. And that brings up a whole other topic maybe for next year around EMF smog, and you know, we're getting into the realm of 5G. You know, we're all basically living in a microwave oven today. But there are so many aspects of the visible light spectrum that are known to have some important biologic effect. We know that UVA light is central to nitric oxide production. And I think the Nobel Prize in 2012 was for the discovery of that mechanism. Everyone is aware of UVB light and vitamin D. These are, of course, outside the visible spectrum and the antimicrobial effects. Now you can disinfect a room of pathogens and C. difficile by just blasting it with some UV light. We just looked at the bilirubin effect from blue light. And again, blue light is a very important chronoactive wavelength. It basically turns our circadian clocks on. And they are highly evolved to respond to that. Well, and that there's good news, bad news in that story. And of course, photosynthesis, right? Plants can turn energy into mass, and that's pretty impressive. And of course, when you look at the chloroplast of a plant and compare that with the mitochondria of a human, they're very, very similar in how they manage light, energy, and at the quantum level, these are very sophisticated capacitors that do so much to influence electron flow. And then, of course, a lot of interesting work on the red end of the spectrum for wound healing, collagen production, nitric oxide as well. You will see in the near infrared spectrum sulfation a really important biochemical process. Many molecules do not become bioavailable until they are sulfated, and red infrared light is critical for that. Those of you that are familiar with Stephanie Seneff's work with glyphosate, she's at MIT. Glyphosate profoundly disrupts sulfation processes, and probably as a consequence, many of the biomolecular processes that require sulfation when glyphosate is introduced become disrupted. And then, of course, mitochondrial function. The mitochondria is a biophotonic organelle, and in both the red and near infrared frequencies, cytochrome C oxidase is very strongly upregulated. It's estimated that about 2/3 of the energy we produce is from light. Food is really responsible for a smaller majority of the ATP that we produce, maybe about 1/3 to 40%. And if you look at the research of Gerald Pollack at University of Washington, his work on exclusion zone water, where you can take water, subject it to near infrared light, and the water molecules will rearrange themselves to create an electronic gradient, a capacitor. And that probably drives a lot of electron flow, what's called quantum tunneling, and very much enhances mitochondrial efficiency. And so water as a network, a communication network, and as a matrix for electron flow, heavily influenced by red infrared light. So you begin to see this diverse array of biophysics, and that's exclusion zone water. If you're not familiar with this work, I'd highly recommend Gerald Pollack's work. I think his work is revolutionary, and well, more to come, particularly as it relates to mitochondrial function. And so much of the radiation that ultimately reaches us is in the visible light range, but the majority is in the infrared range. Of course, we don't see that, but infrared light, as I just suggested, is very biologically active. And we know that with exposure to UVA, UVB light, or even blue light, that it's the concomitant presence of light in the red infrared end of the spectrum that limits the toxicity at the level of DNA and cellular toxicity of ultraviolet light. There's a protective effect when you're getting the full spectral quality of light. And, Alex Wunsch is a German physician, researcher, scientist. He's done a lot of research in this area. I always enjoy listening to him. Really understands chronobiology, and he's a primary care provider in Germany, and has a clinic that employs a lot of light as part of his intervention and the work that he does. And he's a very thoughtful, very bright guy. Of course, the Nobel Prize recently awarded to 3 researchers in Boston. I think they're at Brandeis University, and this was for the elucidation of the mechanisms controlling circadian rhythms, clock genes, and this growing awareness that all of human biology is tightly regulated by clock systems. There probably isn't any biologic process that isn't on a timer, isn't in some way influenced by the relationship between light through our eyes, through our skin, time of day, and ultimate biologic function. We know, for example, that if you consume a meal at 8 a.m. And you do a pre and post glucose and insulin, and you consume that same meal at 8 p.m., same macronutrient mix, you will have a higher excursion of glucose and insulin later in the day. We are more insulin resistant later in the day. And that brings to bear the importance, perhaps, of meal timing. Sachin Panda last year from the Salk Institute gave a beautiful talk on time-restricted eating and chronobiology. And there's something about bringing our meal consumption into a window that's probably more synchronized with the chronobiology of our intestinal organs, if you will, that creates a more compatible handling of the food and the bioavailability of nutrients. And of course, we know many things will affect these patterns, from light quality to melatonin, shift work, etc.
Should there be a renal icon on that?
There should be. There should be a renal icon. Indeed, if you look at what is a normal diurnal dip in blood pressure, you will tend to find a more blunted renin, angiotensin, aldosterone response later in the day than you do it earlier in the day. You will see differences in salt sensitivity earlier in the day compared to later in the day. And we may not think about those biologic differences as being clinically significant, but as people start to become more ill, many of these patterns, I think, accelerate chronic complex disease. And it's such an interesting story now as we begin to understand some of the molecular, the genes that the period gene and the CRY and clock and BMAL genes. This is research that is very much in its infancy, and I think we are learning that these genes are upregulated at certain times of the day that are controlling these clock genes throughout our body. And again, they're very tightly synchronized and largely driven by the effects of sunlight as mediated through the suprachiasmatic nucleus, and every aspect of hemodynamics and oxygen delivery, et cetera. And Bob knows this all too well, and a lot of this is, you'll find in the anesthesia literature that disruptions of these systems very much impact oxygenation, hemodynamics, and again, our critical care settings are perfectly designed to disrupt these rhythms. We are now looking at readmissions in our institution, as all institutions are, and it's pretty clear that independent of the level of care you're getting, the evidence that you're applying, that if the environment is not well suited, post-hospital syndrome will likely bounce these folks back very quickly. And we're now beginning to look at how we can use the environment to influence readmission rates, and that's kind of a radically different way of thinking about it. So much of what we know about disruptions in circadian rhythm and health come from studying healthcare workers in particular, and we know that night shift work is extremely disruptive at all of these levels, and you see a much greater prevalence, right, of metabolic syndrome and obesity and cancer and depression. And so a lot of what we've learned about the importance of entrainment comes from studying individuals whose lives are, by virtue of working night shifts, sort of chronically disrupted. And the Nurses' Health Study at Harvard, which has been going on for over a generation, has found dramatic increases in breast cancer in women doing long-term night shift work. Some studies have shown these prevalences to be even higher. And you've got to put those people and first responders in the same category. Most of them have disrupted rhythms. And there's been a lot published in many mechanisms. We know that if you look at MI and angina, stent thromboses, et cetera, much more common in the early morning hours, probably coincident with early morning surges of catecholamines and cortisol. Infarct sizes tend to be larger in the early morning hours. And again, a lot of research looking at cardiovascular and cancer disease. We talked a little bit about post-hospital syndrome, ICU, delirium. Some of the window technology that I was involved with originally was we put these windows in our ICU and did some research looking at delirium, looking at the use of sedation and anxiolytics, and found dramatic improvements in people that had these virtual windows that were reproducing the outdoor ambient light quality and circadian timing compared to rooms that did not have them. And, we ended up publishing that work, and again, obesity, insulin resistance, all of these, right, diseases of chronic complex origin are clearly.
They weren't real windows; they were virtual windows.
These were virtual windows, Bob. And they would be put into. They were like 4 by 6. They were embedded into the wall. They had shutters. They were beautiful. And you could not tell that these were not actual windows. And we had webcams on the roof of this hospital that would feed real-time images to the window. So it was like you were looking out doors of the building you were in.
Cheaper than punching a hole in the side of the building.
And that was the case we made. It was an economic case. I was interested in the health implication, but it was a cheaper fix. And again, many more mechanisms have emerged more recently. Much of this, of course, stems from disruption of the HPA axis. We know that sympathetic, parasympathetic tone is disrupted. I know everyone here is familiar with heart rate variability. I really like this as a biomarker. And then again, when you look at 24-hour, I've read a lot of 24-hour blood pressure readings through the years, and you just, for a lot of people with cardiometabolic disease, do not see any diurnal drop in blood pressure. It's as if there is no downtime. They are around the clock from a biometabolic perspective, from a catecholinergic perspective, from an adrenal cortisol perspective. They are behaving as if it's 6, 7 a.m. And of course, all of that, as you all well know, is associated with upregulation of inflammatory states, altered glucose, lipid management, vascular reactivity. And there's some interesting research here that I don't remember hearing about these studies. But when you look back, and a lot of these are epidemiologic studies with inherent limitations of correlation, not cause and effect, but over 20 years ago, Grimes and his colleague reported some very interesting cardiovascular disease mortality data, and there were dramatic and strong associations, inverse associations with the amount of time outdoors and likelihood of death from cardiovascular disease. That was in 1996. This is a little more recent study. This was in 2008, I believe, from actually the Journal of the American Heart Association, looking at sunshine deficit and cardiovascular disease. And again, you see dramatic increases in mortality. And this was a hypothesis of the mechanisms, many of them thought to be mediated by vitamin D production. And vitamin D, as you all know, is it's a nuclear transcription factor that probably influences at least 5% of the human genome, and many inflammatory, vascular reactive, myotrophic factors, the renin-angiotensin system, seem to be regulated by vitamin D. And so the thinking was there's something very important about sunlight, vitamin D mediated effects of ultraviolet light, UVB light specifically, and mechanisms that put someone at increased risk for cardiovascular disease. And a more recent study, this is 2016, again looking at sunlight, and again these are population studies. So the best you can do is raise correlations, and the more northern latitudes you are at, the greater the blood pressure in general. And there have been many epidemiologic studies, as many of you know, that suggest the prevalence of many chronic complex diseases are higher at more northern latitudes and less prevalent as you get closer to the equator. And sunlight and vitamin D may only be one piece to that. There are probably many quantum effects of light, and I think we still have a lot more to learn, but clearly there is something to this. This is probably one of the more widely referenced studies from Sweden. Lindquist and his group. This is the same group that's done a lot of work on saunas and really total health benefits of saunas and risk reductions, total mortality risk reductions. It's hard to find any intervention that is associated with across-the-board drops in mortality. Cardiovascular, cancer, Alzheimer's. They look specifically at almost 30,000 women in the early 90s, and they followed them for 20 years. And again, found these dramatic inverse associations. The more the sun exposure, the lower the risk of cardiovascular disease, non-cancer, non-cardiovascular deaths with those that got sun exposure, with much higher increases in those who avoided the sun. And the magnitude of change in those who avoided sunlight was comparable epidemiologically to that of smoking. And so Lindquist had the audacity to suggest that sunlight deprivation was as risky to health as cigarette smoking. And based on at least the magnitude of changes seen in this study, some of the data from his study, non-smokers at the top, smokers at the bottom, those who avoided the sun exposure were these blue lines. So you can see a tendency toward a greater 20-year mortality, no sun, intermediate exposure, and then a lot of exposure in the green. And if you look at those that smoke, clearly smoking and the effect of sunlight appear to dramatically, even in smokers, reduce that risk. You see risk reduction in non-smokers as well, but improvements across the board in all age groups. And again, cancer, and these mechanisms are just fascinating. You know, we know that many of our normal mechanisms that sort of regulate proliferative changes and DNA repair and programmed cell death, apoptosis for rogue cells, immune modulation, become very disrupted with circadian disruption. And once you begin to lose these adaptive protective mechanisms, your risk of cancer goes up. This was in Cell 2016. Melatonin, which of course is tightly linked to these distorted circadian rhythms, lower melatonin levels, which are ordinarily, melatonin is quite protective. We think of it as a sleep hormone, but it really is a powerful antioxidant, helps facilitate DNA repair, apoptosis. It's very anti-inflammatory. Melatonin has many health-promoting effects, and most of the environmental attributes now in modern life will inhibit these normal production and rhythms. And of course, as you all know, the adipokines, fat-related immune signaling is also very prevalent in people who have disruption of circadian rhythms. And you'll see this as, right, obesity, visceral fat, fatty liver, and all of the pro-inflammatory consequences of that phenotype. And again, shift work, health research agenda. This is from some sleep studies, again, looking at cardiometabolic disease. And, you know, they're all essentially beginning to say the same thing, how the stressors of disrupted circadian rhythms, as Bob alluded to, put you in a perpetual fight-flight response. And we know that at the level of the gut biota, you can see changes as a consequence of that, permeability, inflammatory, insulin resistance, and round it goes. And when you add to this, right, the standard American diet and unabated stress and social isolation and adverse childhood events and trauma, you can appreciate the perfect storm that has people on a metabolic trajectory that ultimately dooms them to a life with a much higher burden of chronic complex disease. So this is really the gold standard. Sunlight is, you know, if you look at sunlight as the gold standard of the visible spectrum, this, my light colleagues would say this is the quintessential spectral quality. We've got pretty good and even distribution of the spectral quality of sunlight. This is a typical fluorescent light or compact fluorescent light. You get these bursts of blue light and a very sort of heterogeneous and inconsistent mid-range of green, yellow, and very little on the far end of the red spectrum. And if you look at an incandescent light, much less blue light and preponderance of light across the green, yellow, red spectrum. And this just looks at sunlight here, obviously more intense light, incandescent, you know, a bit less intense, but you can appreciate the difference in spectral quality. And as I've suggested, the biologic effects are not trivial in these differences. And this is a slide that was lended to me from Dr. Wunsch. And again, the point of this is that light on this continuum has a synergy, right? Nature just creates everything in a way that is inherently balanced. And we know that on the red-orange end of the spectrum that this end of the color spectrum doesn't affect our chronobiology. It's a neutral effect. These can be thermally effective. This can be warmer light, which is very therapeutic. Very little oxidative damage on this end of the spectrum. The mitochondria has unique photoreceptors in the 680 red range, in the 820 near infrared nanometer frequencies, very therapeutic. And then on the blue end, the blue light is really the chronobiologically active light. The blue light basically tells your suprachiasmatic nucleus that your day is beginning. And if you were to do spectrophotometry pictures of an early sunset, you get this beautiful spectrum, but you'll see a bit more of an intense blue light. That really tells the human species and other species that the day is beginning.
Did you mean sunrise?
Sunrise, yes, yes. Yes, sorry if I, did I say sunset?
Yeah.
Yeah, sunset is on this end of the spectrum. Thank you.
You said something about LED lights earlier. What, you know, show something what they look like?
Yeah, so LEDs can vary depending on the design of the LED, but I'll show you some examples of that. Yeah. But the point here is that much of our non-native light looks like this and has a preponderance of blue light. And while we need blue light, when there isn't a lot of sort of neutralizing and balancing red, yellow, infrared, which we don't see here, light, you get more oxidative stress, mitochondrial damage. There's probably a growing body of research suggesting macular degeneration, nearsightedness, which is a bit of an epidemic now. You know, a lot of kids are just wearing glasses now, and there's something about the way blue light affects accommodation that's probably disrupting vision. So it's the excess of this and insufficient levels of this that non-native lighting puts us at risk for. And this is kind of an example of some different light patterns. Again, you know, daylight, sunlight being your gold standard, incandescent, reasonable representation, certainly not as much blue light, so it tends to be more therapeutic. Now, compact fluorescent, it's just total junk light. A warm halogen is like an incandescent, much more energy efficient. And then LEDs will come in different forms. The cool white LEDs are the more intense, bright LEDs. They have much more blue light. And these are the lights that you'll find in our laptops and smartphones and high-def televisions and certainly cool white LED light sources. The warm LED dramatically brings that blue light down and puts more emphasis on the mid-far end of the visible light spectrum. So if you look at better non-native lights, certainly a warm halogen with a color temperature 2700 to 3000 K. The color rendering index, the CRI, basically refers to how closely does it mimic sunlight in terms of spectral qualities. So, I'm looking for CRI greater than 95%. I think a warm LED can be a nice alternative as well. And in my office, our facility folks are systematically changing lights out. Of course, we started with the C-suite. I had to get my CEO to buy into this. But he's interested in his performance. He's insulin resistant. And so we now have halogens in many of our office settings. We've gotten rid of a lot of our fluorescent. And in areas where we've had cool white LEDs, we've switched them over. And we still have a lot to learn about the health benefits of that, but it just makes sense that if you can create a more natural color spectral quality in the environments that you are in, it's hard to imagine the downside. And this is sort of a typical iPhone. Again, this is more of a cool white LED. When you apply a filter, they now have night shift. Essentially you're eliminating that spike, getting more of the orange-red light, and that obviously has value. This is looking at the F-Lux app, the blue light filter, and again, this is just the iPad Pro tablet, and again with the blue light filter, you can.
Do you have what night shift does?
I don't know. So I think that the whole blue light story as it evolves, and Sachin last year talked a little bit about blue light in the eye. Melanopsin, a photoreceptor molecule in the eye, was discovered only about 20 years ago. And melanopsin is a blue light. It's a blue light sensor. Its mission in life is to sense the magnitude of blue light, and it's signaling through the suprachiasmatic nucleus. So clearly, it appears to be associated with that, again, that daytime awakening and turning the on switch of circadian rhythm. But if you're getting an excess of blue light at night, you're having the opposite effect. You're basically suppressing your melatonin, and we've talked about the implications of that. Cortisol will not be blunted as you would expect because it's 10 p.m. but your brain thinks it's 8 a.m. And you're all well aware of the adverse metabolic sequelae of that. We know that sleep disruption and then all of the many consequences of that, jet lag, circadian disruption are powerfully induced by that. So part of the current thinking is that we have an excess of blue light. We're in blue light toxic environments. We have adapted to be getting blue light more in the earlier part of the day. And because our non-native light is not only more blue dominant, but doesn't have as much of the orange-red end of the spectrum, that the toxicity of blue light is made greater by that. And I think this is going to continue to be an important public health focus. And as I alluded to, melatonin will plummet with excess blue light at night. And again, it's much more than just a sleep hormone in terms of its antioxidant activity. It antagonizes aromatase, so it lowers estrogen levels. It may be one mechanism whereby women working long-term night shift have greater risk of breast cancer. Very important immunomodulatory, and again, that's a very disruptive problem when you have chronic suppression of melatonin. I do think this potential relationship with age-related macular degeneration is an important one. Everyone here knows that this has now become one of the most commonly acquired reasons for blindness, and treatments tend to be somewhat limited. And again, blue light is a very powerful pro-oxidant, and with each passing generation, we're getting more exposure to that. So I do think there may be some important implication for protecting one's retina, as well as visual acuity. I'm winding down here. Michael Hollick is, I think, one of the best people in the United States in this work. He's at Boston University, and Hollick, like most outside-the-box thinkers, has been totally thrown under the bus by many of his colleagues. You all know academia is a blood sport, and it takes a lot of gonadal integrity to come out against mainstream thinking. And Hollick has done that, and he does it with credibility that very few people could sort of maintain. But he was one of the first. I think of him as a whistleblower. 15, 20 years ago, he was on the IOM for vitamin D recommendations, and totally outside the box, and suggesting that we needed much more ultraviolet light, that sunblocks, they may protect you from ultraviolet light, but they totally obliterate your ability to make vitamin D and to sulfate vitamin D, which probably makes vitamin D more biologically active. Sulfation is a critical adaptation of the molecule functionally, and taking a vitamin D supplement is not the same as generating vitamin D from UVB exposure to the skin. You do not get the sulfation that you would otherwise get through sun exposure. I don't think we know what that difference might be clinically, but as many of you know, many vitamin D interventional trials have failed to demonstrate the benefit that one might predict based on the epidemiologic data, and there are mountains of it, suggesting that low vitamin D levels increase the risk of every chronic complex disease. But the data around taking vitamin D supplements and mitigating that risk, I think, has, at least to date, been unimpressive. But that's different than getting it through light exposure. So, it can be said that more thoughtful sunlight exposure could reduce cancer incidence by as much as 50. I mean, that is a, there was a drug that could do this, right? People would be just, dancing in the streets. And interestingly, melanoma risk may be lower in people that get more sunlight exposure. People who work outdoors actually tend to have a lower melanoma risk than people who don't. That runs totally counterintuitive to mainstream thinking. One reason for this may be that when you get sun exposure, particularly at a younger age, you start becoming more conditioned. You're making more melanin. That melanin allows you to spend more time in sunlight with more protection from UV light. And over the area under the curve over a lifetime, if you're getting regular incremental dosing of sunlight is ultimately protective. I just wanted to bring this paper to your attention. I think it's one of the best reviews I've ever seen. Very thoughtfully done by Hollick and his colleagues. It will totally shatter everything that we have been taught from a public health perspective about sunlight, and it really having a much greater benefit than risk in terms of the big picture. And again, most of us living north of 32 degrees latitude will not make vitamin D over the winter season. Yeah, the UVB just is not there during those times of the year. Now, that's not to say that you don't benefit from being out in the sun, right? You're getting the red.
Circadian rhythm induction is
Yes,
different than vitamin D.
exactly. Those are different mechanisms. So I think the vitamin D story is very incomplete, but as a surrogate of light quality UVB exposure, the extent to which gene expression patterns are profoundly influenced, and we know that many of those can give us greater metabolic resilience is very, very important. And this is a moving target, but I think that anyone who can get their levels at least to 30 with as much light as the primary source of this is serving themselves well. And there are ways you can do that. I use I live in the Berkshires, Western Massachusetts, so for 6 months out of the year, I'm not getting UVB light. So I use a Spurdy lamp. This is a UVB lamp. I do 5 minutes front and back.
10 minutes total.
I do 10 minutes total. And I follow my levels, so I like to keep my levels between 30 and 50. This Hollick's group has researched this and have found everyone's skin type is a bit different, but the dose response in terms of vitamin D would approximate early morning sunshine exposure. This is about, I'd say, maybe 20 inches.
You stand in front of it?
I set it up on a little table, like desk, and I'll just take my shirt off, and I'm not staring into it. I'll have my back to it while I'm reading or looking at the computer, and then I'll turn front side. I'll have some glasses on just to block the UVB, and I do that 10 minutes a day. And again, it is interesting how if you look at girls that get more sun earlier in life, much lower risk of breast cancer later in life, and there does appear to be a dose effect. There's probably some protective benefit when you get earlier in life exposure as compared to later in life where you haven't developed those protective mechanisms. At least
later in life you get some other health.
Absolutely. So this is Michael Hollick, and occupational sun exposure decreases the risk of melanoma. Imagine him showing this to his Boston University colleagues. If you look at some of these Ancestral, most of them will run, when you look at their vitamin D levels, in that range. And again, full spectrum lighting, of course, as many of you know, 10,000 lux, very important for reducing seasonal affective issues, which are very prevalent. I find certainly in New England, a lot of people have issues with that. And again, many mechanisms here. I know you're aware of this, but in terms of mood, energy, entrainment, better sleep, that early morning full spectrum exposure can mimic sunrise, and you get that full spectrum light, and it's probably a good way to reset one's circadian clock. UVA light, nitric oxide, again, this is a really important mechanism. I think Daria's, in what we will be hearing in terms of the power of light. Now this is UVA. You will also find effects, as I'll show you in a second, with red light, particularly in that 680 nanometer range. But this is when you look at UVA and UVB, it's fascinating, right? You're getting vasodilatation, you're enhancing your melanin production, you're obviously making a lot of vitamin D and probably circulating more of that sulfated vitamin D. You start to see these interesting synergistic effects and these wavelengths of light. And we know that UVA light, as well as the red end of the spectrum, can lower blood pressure and have a powerful vasodilatory effect. And again, this photobiomodulation is so fascinating when you look at the red light, near infrared, that 600 to 800, 900 nanometer range. Powerful effects on the mitochondria, particularly cytochrome C oxidase, which is activated at a wavelength of 680 nanometers. You'll see improvements in ATP production. Reactive oxygen species here is a hormetic effect and upregulates NF-kappa B, AP1 expression, and you get many resiliency effects from that. in addition to the nitric oxide. And again, cytochrome C oxidase, which is in the electron transport chain, this is a photoreceptor protein at 660 to 680. You get absorption at that frequency, as well as in the 830 to 840 range. This is the cytochrome C oxidase absorption patterns. And again, from electron transport, and I think most of human health probably in some way is connected to the flow of electrons. At quantum level, it's all about electron flow, gradients, and light just has powerful mechanisms in mitochondria in that way. And again, a lot of research, a lot of it from the military in terms of red infrared across the continuum into the mid and far range, from mitochondrial function, wound healing, hair regrowth, a lot of interesting regenerative and cellular changes, allergic rhinitis, MS, skin, collagen. This list continues to grow, and now there's a great deal of interest in Alzheimer's, and I think of light as an adjunct to all the amazing stuff that Deb shared with us yesterday on chronic inflammatory response syndrome. And you can get very inexpensive sources of red light and infrared light. You don't have to pay a lot to get a sauna. There are cheaper sources of that. And so these are the Zeitgebers, right? Bright natural light in the day, orange light at night, right? Daily movement, intermittent fasting, all the things that we talk about, and the many ways that they exert benefit have additional benefit in circadian entrainment, cool nights, a lot of daytime social interactions, and this is sort of my checklist when I'm working with folks, trying to help them trade out some of the non-native junk light that they spend a lot of time around. Get them to think about sensible sunlight, right? You don't want to burn, but to become less fearful of getting out unprotected, particularly earlier in the morning, later in the afternoon. Not wearing sunglasses, right? From the minute you get outside to, our eyes really are photoreceptors, and so allowing some exposure there, I think, is very important to allow these systems to calibrate. Considering a vitamin D lamp, if a person can afford it, they run about $450. I have to say, I haven't had an upper respiratory infection in probably 3 years. There may be many reasons for that, but I think this has helped me. And again, incandescent, halogen, warm LED, these are all good replacements for compact fluorescent lighting. Getting rid of these CFUs. Considering blue blockers, particularly when you're around maybe a high-def television, or if you don't have a filter for some of your technology. Full spectrum lighting earlier in the morning for seasonal effective can be very powerful. And obviously non-invasive intervention. The many apps that people have talked about, most that I have played with are the Iris app and the Flux. Iris is like $2.99, and then time-restricted feeding is also a powerful Zeitgeber, and so that's thank you.